Everyone, welcome to my YouTube channel. Today I have picked merge sorted array problem. This problem belongs to top 150 important interview questions. So this is an easy problem. Let's first understand the problem. It says that we will be given two arrays and they are in sorted order only. We have to return, we have to first merge both arrays and the output should always be in sorted order. So this is the whole gist of the problem. Let's read out this. You are given two integer array sorted in decreasing order. Merge num1 and num1 and num2 array. They are single array and they are sorted in non-decreasing order. So the final sorted order and here one thing also we have to keep in mind, that it is clearly said that we don't have to return anything. Whatever we have the result, they should be copied into nums1 only. So let's see what approaches we can put here. First approach we can do, we all must have heard about merge sort problem, so we can do it in merge sort style. We can take one extra space and then we can pick the smaller element out of the, we can iterate both of the arrays through both of the array elements. We have to compare at every element, every level we have to compare the elements, like similarly we do in merge sort. And then the result, the smaller element, we have to copy one by one, and then in the end we have to copy the result back into nums1, and then it will clearly return it. But the problem here, so let's see first how this will work. We will iterate through first array and second array. So if we see at we have this element one. Sorry, the first time I'm using this pen. Yeah. So let's first write here. You see we have 0, 1, 2, 3, 4 and fifth index. And in the second array we have 0, 1, 2. So let's compare every element here. So if we compare every element, we see that uh, at if we see at we have I, and we will, let's first iterate. Okay. So we have, sorry, yeah. So at ith index, let's do it quickly and then we will move towards the optimized solution. So if we will compare the first element from this array nums1 and first element from this array. So we see that at nums1, like nums1 of nums1, nums0 is smaller than nums1 0 is like first element of nums1 is smaller than first element of nums2. So clearly we have to write 0 in the result array, and then we will move forward, and we will increment this element. So clearly this is done, and now we will compare element 1 from nums1 and element 0 from nums2. So element we can write it like this only. Sorry, this is going to be 1, and then we have 2, and then in the result array itself we will have 2. Just give me 1 minute. Yeah, so now we already have process 2. We can take any of it. We can take this as well, we can take this as well, similar to merge sort. And then we have this 2 as well. Now you see that we have processed both of these, both of the 2's. Now it's time to compare these elements. Like whenever we have, like similar to merge sort, whenever we process the element, we increment the pointer. So now it's time to compare 3 and 5. When 3 and 5 would be compared, then we know that 3 is smaller, so 3 is going to be put in the resultant array, and then 3 is also already processed. Now it's like 0 0 0 and 5 6. So we know that we have reached till the end of this array, or not even end of this array. Then we have this end of these elements. Now we don't have to, we see that 0 0 0. So length is, you see, you don't get confused here. We already know that the length is already given in this question, in this problem. We see that we have to process only first three elements. So 0 1 2 3, first three, length of the element. So after this we know that we have reached till the end of the nums1. This 0 0 0 is given because we have to maintain the m plus n size. This is given in m plus n size, but we know that elements are up till here. Now we can process these elements. So once we reach this, we can quickly fill out this rest of the elements, which is 5 and 6. So you also see that the output where we were given to generate was 1 2 2 3 5 6. So resultant array can be this was a resultant array which which I did in merge sort fashion. But here you can see in this approach the algorithm is clearly the same as merge sort, only like we have created a new array, then we have taken two pointers, and we are moving the pointers according to the array size, and then we are pushing the smaller element, and then we are copying back the element merged array into nums1. But here you see that we have this space complexity. So interviewer is clearly not going to be happy with the extra space we are taking here. And the time complexity is m plus 1, because whatever the array size is, we have to do the time complexity according to that. Now we can optimize this particular solution in using the two pointer approach. So here in the two pointer approach, we what this two pointer approach is, first let's first understand that. Now we can use two pointer approach from starting as well, ending as well, but I will tell you that what approach is going to be optimal. If we start the two pointer approach using like in the starting of the array, from the beginning of the array, it is not going to be that optimized. We have to use we have to use the two pointer approach from the back. I'll tell you why I'm saying this. So this is two pointer approach. Okay, this is two pointer approach, and this is going to be from end only, not start. So the reason behind this is, in this particular question, the reason behind using the two pointer approach from the back is that if we do it from the beginning, we see if we start the two pointer approach and we started filling out elements from the beginning, then we might lose the initial elements from the nums1, right? And since we know that the nums1 has 0 0 0 for this particular problem, in the end this given like 0 0 0, we can start filling out elements, and we don't have any we don't have any chances or any danger of losing the elements. That's why we are going to start, or let me reiterate. If we start both pointers from the beginning of the array, then the smaller value, and take smaller value each time, and then create a merged array, then the extra elements, then the like the initial elements are going to get overwritten. So this is clearly the reason we are going to start from the ending. Or if we don't start from, if we start, even if we start, if we want to start from the beginning, then this is clearly going to be, and we don't want to lose out any elements, then only merge sort type of approach is going to be left. So we are going to start the merge process from the ending only. Now let's start how we are going to do it. We are going to take elements from, like we are given j I, we will take I j, and we are also using a third pointer. The third pointer is needed because we have to keep track with that we at which point we are. So a third pointer is also going to come into the picture. We are going to initialize all the pointers like I j. I is going to be initialized by like m minus 1. M j is also going to initialized by n minus 1, and there is a third pointer also in the picture. See, this is a very important thing which I am mentioning right now, that it is going to start from m minus 1 m plus n minus 1. So see, clearly we are given that the length of this array is going to be m plus 1. So if we want to start from the end, we have to take m plus 1 and m plus n minus 1. And if you have ever solved any MCQ type of questions, or ever come across any such questions where merge sort is given and then the length of the resultant array is being said, this is a very, very important thing, my friends, that this is going to be m plus n minus 1. You must have come through such kind of MCQs. So this is a very important snippet from any placement point of view or any placement MCQ as well. So just keep this in mind. So now let's move ahead and try to solve this problem. So k is going to be initialized from this m plus n minus 1. So if I go and write the indexes, here it is, give me one, I'm a bit slow with this right now, sorry. Yeah, so here this is 0. Again there is some issue. Okay, I think now it should work. Yeah, so it is 0. Some problem in my pen. Yeah. So this is 0, now 1, 2, 3, 4, 5, fifth index, and now this is 0, 1, 2, second index. And this is going to be like the I is going to manage this, J is going to manage this, and K is going to manage the resultant array indexes. Okay. And now we can, sorry, I is going to start from end. Yeah, don't get confused here. And let me write it at the end only. Yeah. So we will start from k and the resultant array. So let's write first what is the length of the resultant array. 0, 1, 2, 3, 4, 5, 6, 7 only. So this is going to be the exact length of the resultant array. And we are going to start from end. So we first this 3 and this 6 is going to get compared, and whichever element is greater, we will put that into the resultant array. So 3 and 6, if we compare, 6 is greater, so 6 is going to come to the resultant array. Now 6 is already process, so the pointer, j pointer, will move backward, and k is also come backward. Now 3 and 5 is going to get compared. Clearly 5 is greater, so 5 is going to come to the resultant array, and 5 will move, j is going to move backward. Now 3 and 2 are going to get compared. 3 is, sorry, sorry. Okay. So 3 is going to be the come into the resultant solution. Okay. So 3 is going to come to the resultant solution, and since 3 is already processed, we are going to decrement our I. I at this point is 1, and j is at 0th position. I is at first position, and we already have filled our k up to this index. Now the k is decrementing, and whatever element we are picking from whichever array, that index is decrementing. Now 2 and 2 is going to get compared. We can write the value from any of the array, and this value is going to get processed. And similarly we are going to move backward, and then 1 is going to get come into the resultant solution. So this is how we are going to process. This is a very easy problem, and let's first quickly write the code, and then we will come back. And also first time discuss the time complexity. The time complexity is clearly going to be big O of, and this is also a very important question from the interview point of view, that the time complexity of merge sort. So this is also, please remember this point. And since we haven't used any extra space, we have done everything in place, so no extra space is used. So this is the optimization we have done. This is a no time complexity, big O of 1 time complexity. Let's first code this. I writing it in a JavaScript. Whatever language suits you guys, please do in the same language. So we have this I. We have taken the I, remember, and we started from the end of the index, right? And also please try the merge sort approach. That is also very easy way out. So please do try that. And then we took a third index, which was m plus n minus 1. Remember, I told you this is a very important point from the interview MCQ perspective. So also keep in mind this approach, this point. Okay, now we will start off and then we will compare. We have to reach up till any. If we reach at in any array, we have reached this zero. We can break the loop or we can come out of the loop. And remember, what I did was I was picking elements from. I was picking larger element from any of the arrays. So I am picking larger element from any of the array, and the third index I am going to fill. And since there is no problem of overriding the value, because whatever value I am, remember, this is a very important thing, that we know that array is sorted, so we don't have to worry about the overriding problem. And what happens if we exhaust all the elements, and since the array is sorted, so the output is always going to be right only. Don't worry about that. If we exhaust the elements from nums2, and then what would happen if we haven't elements in place at nums1? So that is never going to be the case. If we exhaust values from nums1 and we come out of the loop, then the values in nums1 is already sorted. So at any point we have to copy the value in nums_k only, or insert the value. And if the value at is nums greater at nums1, then we will put the value of nums1. If the value is greater from nums2, then we will put the value from nums2 of j. I is for nums1 and j is for nums2. And also, whenever we are picking the value, remember we were doing minus minus. We are decrementing the pointer. So whatever array we are taking the value from, we have to decrement the pointer from both of the array. And see, clearly we can see that we are at every step we are entering value in using the k index. So at any point in every iteration, we have to decrement the value of k. And suppose we have reached till the end of the nums1, or we have exhausted all the values from nums1, but there are still values left in the nums2. Then what have to be done? Just simply we have to come till we have to use the j pointer, and then we can simply paste the values or insert the values from nums2. K minus minus, and we don't have to return anything, because it is clearly said in the problem that whatever value is going to be, we have to paste it back in nums1. Since we are doing it since the beginning, so we don't have to return it. Everything is going in nums1 by default. See if the value the approach is accepted. Let's take. So yeah, problem is submitted now. Do try this problem. Do try to do this on your own and use this approach. Okay, and see, this is the way we have done. Let's do a quick summary of whatever we have done till now. So what approach we used? First approach was merge sort only. So we did merge sort. Merge sort is very easy. Please do it on your own as a homework. Please see how we do merge sort. This way you will learn merge sort as well. And the second approach was two pointer from the end, not the beginning. What I told you in starting, that if we take the values from the beginning, we might lose the values from nums once. That's why we start from the end only. We initialize the with three pointers and all of them from the end. This is a very important question from the interview purpose as well, MCQ. So yes, keep this value in the mind. And we compare the values from both of the arrays. We take the larger element, we put it back in the free space, and yes, so yeah, this is how we do. We put it back, and then if we any elements is left from the nums2, we copy it back in the nums2. This is the time complexity. Thank you for watching my video. Do dry run, do everything on your own first, and try do writing the code on the pen and paper as well. Thank you for watching.